In this video, I'm going to talk about the atomic structure. I will be going over subatomic particles, the regions of an atom, the difference between cations and anions, how to find the average atomic mass, and how to find the number of atoms given the percent abundance of each sample. First, I will start out with what are subatomic particles. There are 3 of them. Protons, which are positively charged, neutrons, which have a neutral charge, and electrons, which have a negative charge. Next up will be the regions of an atom. An atom is made up of 2 things, a nucleus and electrons surrounding it. The nucleus is small and dense and is made up of protons and neutrons. Surrounding the nucleus is electrons, which is mostly just empty space. Next, I will go over how to find the different parts of an element. You clearly have the element name and can find the symbol on the periodic table. You can also find the atomic mass, which is the number below the symbol, and the atomic number, which is above the symbol. You can also find the number of protons, neutrons, and electrons. The protons and electrons are the same and also happen to be the atomic number. To find the neutrons, you take the atomic mass and subtract the number of protons. Now I will talk about the difference between cations and anions. Cations are positively charged and lose electrons. An example of this would be sodium. It has to lose an electron in order for it to have a full outer shell. Anions are negatively charged and have to gain electrons in order to have a full outer shell. An example of this would be fluorine. It has to gain 1 electron in order to be full. Next is how to find the average atomic mass given different sample sizes. You find it by multiplying the percent abundance in decimal form by the mass of the element. Then you add that to the product of each pair of samples. An example of this is that you have an unknown element with 3 isotopes. One isotope has a mass of 23.9850 that exists 78.99% of the time. A second isotope with a mass of 24.9850 that exists 10% of the time. And a third with a mass of 25.9826 that exists 11.01% of the time. And if you plug that all into your calculator, you should get 24.31. Lastly, I will show you how to calculate the expected number of atoms in each isotope. Using the table, find how many are in each if you have 356 atoms of magnesium. All you do to find it is take the expected number of atoms and divide by the percent abundance of each sample. For this sample, you would do 356 divided by 0.7899 to get 281 atoms. You repeat this with the other samples. Thanks for watching. I hope this video helped you understand a little bit more about atoms and the atomic structure.